Hi, this is Mr. Janes. In previous videos, we've talked about triangle congruence, and we've explored some shortcuts we can use, or theorems we can use, to show that two triangles are congruent, even when we don't have all the sides and all the angles labeled. Things like side, 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 and side, angle, side. Soon we're going to start writing formal triangle congruence proofs to show that two triangles are congruent, and even farther than that. To get ready for this, though, we're going to complete this graphic organizer we have in front of us to list all the different ways we can show triangles are congruent. On the back side, we're going to list some common given conditions that we might see in a triangle congruence proof. So this piece of paper is going to be very important to us. Make sure you follow this closely and don't lose this graphic organizer as we go ahead. So let's start. In the middle, there's type of congruence and notation, and this is filled in throughout the entire graphic organizer. To start, we've got the two definitions we have for congruence that we learned a few weeks back. The first one is the two triangles can be mapped or transformed onto each other, and the second is that all sides and angles are congruent. And these are remember the two definitions we learned, basic definitions of congruence. So the first one, the two triangles can be mapped or transformed onto each other. Let's make a quick figure of what that means. Like if I had one triangle here, and maybe another triangle, say, over here. Maybe I would first translate the first triangle over to here. Okay, and maybe I would reflect that triangle, okay, over to here. And finally, maybe I would rotate that triangle down to meet the second triangle. So what I've done here is I've translated, I've reflected, that green, and I've also rotated. And those three things, as we know, are all transformations that preserve the rigidity or the shape of that triangle. And yes, those are ways to show that two triangles are congruent. And they are because that was one of the definitions. This is definition number 1 for congruence. One of the most basic things. The second basic definition we have is that all sides and angles are congruent. So suppose I've got one triangle here. I've got a second triangle right here. The most basic way to show that they're congruent, or the second way, is to make sure all the sides are congruent. All the corresponding sides are congruent, just like this. Okay. And to make sure all of the corresponding angles are also congruent, like this. 2 tick marks there, 2 marks there, 3 here, 3 here. Okay? And so we can say that those two triangles are congruent because of all their corresponding angles and sides, all their corresponding parts are congruent. And so, is it a congruence theorem? Well, yes, it's not really a shortcut or a theorem, it's just definition number 2 for congruence. So these first two are really our most basic definitions of congruence. Okay? After this, we're going to start to move into the shortcuts, those theorems that we explored. I'll do one with you, then I'll have you pause the video and try and fill in the rest yourself. I'll start with side, side, side. Alright, so side, side, side means I've got two triangles. One here, and one here. And side, side, side means that there are three corresponding sides that are congruent. So I'll mark my triangles just like this. Just like this. 1, 2, 3. 1, 2, 3. Alright, is side, side, side a condition for two triangles to be congruent? Yes! Yes, it is. It's one of our theorems or our shortcuts. So yes, it's a theorem, or sometimes we call it a shortcut. Because what side, side, side allows us to do is not check any of the angles, just the three sides. At this point, I'd like you to pause the video and try and fill in the remainder of this graphic organizer. Pause the video in 3, 2, 1. Alright, so let's start with angle, side, angle. And so angle, side, angle is when you've got two angles, okay, two pairs of angles, that's one pair of angles. There's a second pair of angles, and a congruent side in between those two angles. Notice how this side right here is between these two congruent angles, and the same thing in the bottom triangle. Okay. Another example of angle side angle might be if you have, I don't know, these two sides congruent and these two angles congruent, and you leave it at that. Because actually you can fill in this middle angle right here, and now you've got an angle, a congruent side, and an angle where the side is between the two angles. And so just to make sure we know that that's between, I'll mark that right there. And angle side angle, we learned last time, is a theorem or a shortcut to show that two triangles are congruent. Next, side angle angle. So side angle angle, similar to angle side angle, except this time the side is not between the two angles. So you might have maybe an angle here, another congruent angle here on both triangles, but then the congruent side is not between those two angles. So perhaps those two sides are congruent right there. Another example you might see of this is if you had perhaps a congruent angle here, both of these triangles, a congruent angle here on both of these triangles, and then this last one maybe could be this shared side, this reflexive side. Again, the side is not between the two angles. Side angle angle or angle angle side. Either way works as long as the S is not between the A's. And again, yes, this is a shortcut we can use to show that two triangles are congruent. Next we have side angle side. This is where you've got maybe two sides that are congruent. So that's one pair of sides. There's a second pair of sides, and the angle in between, okay, congruent. Again, the angle is between two sides. Another example might be if you had, let's say, this side was congruent to this side was congruent to this side, and then because you've got two parallel lines here, you can fill in this alternate interior angle here, and again you've got side angle side. Remember, the angle is between the two sides, and yes, this is a congruence theorem. We're going to skip side angle and hypotenuse leg just for a second and come down here to angle side, angle, and I'm actually going to add my own here. Make sure you put this in. Angle, angle, angle. Okay, so angle, angle, angle. And so none of these actually work. So right off the top, let's just write no. None of these work. So whether you've got an angle that's congruent both triangles and one side, so that's one angle and one side is filled in, that doesn't work, just having those. Having two congruent sides doesn't work. No, that doesn't work. Having two pairs of congruent angles, that's one, that's two, that doesn't work. And not even having three pairs of congruent angles makes the two triangles necessarily congruent. Those do not work. So none of these will work. What about side angle and hypotenuse leg? Well, these are a little more interesting. Okay, side angle doesn't work, but hypotenuse leg does work. And you maybe haven't heard of hypotenuse leg yet, so I'll show you what that is right now. Remember, side angles, if you've got two triangles that have one congruent angle, a congruent side, okay, and another congruent side, and the congruent angle is not in between those two sides. See, the angle right here is not between the two sides. Now you might be tempted to say, well, those two triangles look pretty congruent, so they're going to be congruent. But in fact, they're not. We can take this blue side right here and turn it in to the triangle just like this, so that it's the same length as this side over here. In fact, I'll move these right in. It's the same length, but it's not going to be congruent at all. So if we go back here, definitely not going to be congruent, not at all. And if we see, we get the same thing if we shorten this leg a little bit, right? If we try and shorten the leg, we can still do this thing where we swing that leg over. In fact, let me draw a little circle here to show you what I mean, right? I can still take this leg, this side right here, and swing that in, and even though the sides are congruent, not a congruent triangle. If we make the leg a little bit smaller, right, this blue side, still, right, we can swing this in, and we still have angle, side, and it is not a congruent triangle. But wait, what would happen if we made this a 90-degree angle, if this other leg was straight up and down? Well, let's see. If I try and draw my circle again, there's nowhere to swing this blue side to, right? Nowhere to do it. It won't hook up with the black side again. And in fact, if you have two triangles, okay, two triangles that have maybe a side angle, and that angle is a 90-degree angle, then those two triangles are congruent. Yes, those two triangles are congruent. Now, we call this a special name. We call this hypotenuse leg congruence. Hypotenuse leg because in a right triangle, the longest side is called the hypotenuse, and the shortest side, or one of the shortest sides, is called the leg. So if you've got a right triangle where the hypotenuse, the two hypotenuses are congruent, so this length, and the two legs are congruent, there and there, and you've got the right angle on both of them, we call that hypotenuse leg congruence, or HL congruence, and we can say those two triangles are congruent because it's just like side-side angle, or angle side-side, however you look at it, but it works because this blue side right here has nowhere it can go if it's a right angle. So while something like side-side angle does not work, hypotenuse leg, so side-side angle with a right angle, does work. So I'm going to go ahead and fill in side-side angle and hypotenuse leg with the pictures we've just drawn, and also write that side-side angle does not work. No. I'll put that in right now. No. But hypotenuse leg does work. Yes. And there's a quick figure of side-side angle. It doesn't work, remember, because we can swing that last side in, and they're not congruent. But with hypotenuse leg, it's the same as side-side angle. It's the same, but it has that 90-degree angle. And that 90-degree angle makes it so that we can't swing that leg in at all, and those two triangles are congruent with hypotenuse leg. On the back side of the sheet, we've got some common given conditions for triangle congruence. We've got a picture, and what you've got to do is figure out which two angles are congruent and what theorem causes them to be congruent. And these are going to be important when we start doing triangle proofs. Here's how I want you to fill them in. First, look at the picture and decide what it's telling you. In this case, line A is parallel to line B. Then write an arrow and write down what that tells us, or what that gives us about these angles. So, since line A is parallel to line B, angle 1 is congruent to angle 2. And the theorem, well, why is angle 1 congruent to angle 2? That's because of the alternate interior angles theorem. We've got two parallel lines. These angles will be congruent by the alternate interior angles theorem. Pause the video now and try and finish out the rest of the sheet. The answers will appear on the screen in 3, 2, 1. For the next one, we have that B is the midpoint of AC, and that means that AB is congruent to BC. That's because of the definition of a midpoint, or if you want to be a little fancier, you can write this full sentence. A midpoint splits a segment into two congruent smaller segments. For the next one, we have that AB is a shared side between these two triangles, and so we write that AB is congruent to AB. That's because of the reflexive property, or, be a little bit fancier and write out the full sentence, we can say that AB is always congruent to itself. Again, that's the reflexive property. Next up, angle A and angle B are vertical angles, right? They're across from each other just like this, which means that they are congruent. Angle A is congruent to angle B. The reason? We see the vertical angle theorem, or if you can be fancier and write out the entire sentence, vertical angles are always congruent. Right over here we've got that ABC is an isosceles triangle with AC congruent to CB, which means that the base angles, angle A and angle B, are congruent. That's because of the base angle theorem or the isosceles triangle theorem. If you can write that as a full sentence, it would say the base angles of an isosceles triangle are always congruent. Here we have ray BD bisecting angle ABC. And what that means is that angle ABC is congruent to angle DBC, these two angles right here. Why is that? Well, the definition of angle bisector, or to be a little more fancy, a bisector cuts an angle into two congruent angles. That would be the full sentence if you're explaining this out loud to someone. Otherwise, you can just use the theorem right here, the definition of angle bisector. In the next figure, we have two pairs of angles that are congruent, and that means that the third angle, the third pair of angles, I marked them A and X, will also be congruent. This is called the third angle theorem, or if two pairs of angles in a triangle are congruent, then the third pair is also congruent. And lastly, given. Any information already marked or given in the diagram can always be assumed. When you write a triangle congruence proof, you will only need to write down the name of the theorem circled in yellow, but it will still be important to remember everything else that goes along with it. Don't lose this paper as we start to do triangle congruence proofs.